Okay, so now let's take a look at an example. So I have the function g of x is 1 to x. Integral from 1 to x, 1 over t to the power 4 plus 1. And now we want to find the derivative of that. So g prime. G prime gonna be d over dx a to x ft dt gonna be equal to fx. So we just take the function, whatever the function, and replace t by x. So we have the t to the power 4, so that become 1 over x to the power 4 plus 1. So nothing changed to this. But for the second one, we have x squared is actually not a single function like x, right? Not just a linear function like x. So we're going to have a chain rule. So when we have chain rule, then we're going to have to take the derivative of a p of x ft dt will become f of px times p prime of x. So that will give you sine of, so f prime x will be sine of x squared times 2x. Okay, and that's gonna be the answer. So again, don't multiply x squared and 2x because that's gonna be change your answer. So it's better to bring them to the front. So you have 2x sine x squared. Okay, and now let's take a look at the last one. The last one, you have the lower bound and the upper bound is actually a function. So you're gonna have to use the fundamental theorem part 1. So we have d over dx integral from px to qx, or qx to from qx to px, f of t dt will be equal to f of the upper bound p of x times p prime plus f of a lower bound times q prime. Okay, so my upper bound here is 3x squared. So f of the upper bound is mean I'm gonna replace everywhere I see a t by 3x squared. So we're gonna have f prime of x will be square root of 3x squared to the power 2 plus 2 times p prime. So it's gonna be 6x plus or minus, I think minus. I put the formula wrong, it's a minus. Minus square root of 3x squared plus 2 times minus x squared plus 2 times 1. Okay, and we're gonna have the result will be 6x times square root of 9x to the power 4 plus 2 minus square root of x squared plus 1 plus 2. Okay, so this technique is using the formula. If you don't want to use formula, it's fine. You can also break them into two different integral. So you have integral x to 3x squared, square root of t squared plus 2 dt. Then you can break them into two different integral. You have x to whatever the number a, square root of t squared plus 2 dt plus a to 3x squared, square root of t squared plus 2 dt. You don't have the fundamental theorem part 1 from to taking the derivative from x to a, but you have the derivative of the integral from a to x f of t dt is fx. So we want to rewrite this using the property. The property say if you have f, the lower bound is a, the upper bound is b, f of x dx is gonna equal negative ba f of x dx, right? So you can put the negative in the front and then change the bound, and then you have square root of t plus 2 dt. And then the second one is fine because the lower bound is constant and the upper bound is variable. And then now, based on the fundamental theorem part 1, we have negative square root of x squared plus 2. And then plus square root of 3x squared plus 2. Oh, I keep, yeah, that's right. And then times 6x. If we rewrite this, I have negative square root of x squared per 2 plus 6x times 9x to the power 4 per 2. So this will give you the same answer as this. Okay, so it's up to you if you want to do this or this. And make sure you put the d over dx. Okay, d over dx. d over dx, d over dx. Okay, and that's how you do the fundamental theorem part 1.